Hi there, software engineers. Today we're going to start learning about how the internet actually works. Kind of. There's a lot of stuff that's going to go into that particular question. There's all sorts of networking aspects of it, how the packets get routed. Yeah. That's fun and exciting stuff. Go take a networking class. What we're going to talk about, though, is how this actually works from a web application perspective. And, we're building our projects in Django with Heroku as the hosting service. You might be using something else if you are watching this video from another location, but the history stuff here, it's kind of the same thing for everyone. And it starts with thinking about how the web actually evolved. You know, I remember in the long ago in the way back times, back in, gosh, 97, 1998, when I was really starting to use things like AOL Instant Messenger and going to websites. Even before then, I remember going to camps where we learned about the beginnings of this cool thing called the World Wide Web. Fast forward to today, and it's changed a lot, a whole lot. And part of this is because our needs for the internet have also changed. So it's really important to know that in the beginning, when we looked at the World Wide Web, it was really just a file server, and then now it turned into web applications with all this fun and exciting stuff on the background doing. Anyway, let's talk about it. So in the long ago, in the way back time, when Tim Berners-Lee was first proposing what the World Wide Web was going to be, it was a connection of interlinked documents, hyperlink, the A tag if we're making an HTML page, right? Hypertext markup language. So we started with what was just effectively a file server. So on your machine, on your desktop, desktop at that time, I guess there were laptops, but on your desktop, you would make a request to a URL, a uniform resource locator, and say, hey, server, I'm super interested in your web page. Could you please send me index.html? And on the server side, it was just a folder that the web server was looking at. Okay, let's differentiate servers here really quick. So there's the physical server thing, box, lights on it, plugs into a wall. Actually, they're more kind of like flat now, I guess, in server racks. But you have the server, and that server runs some servers. Sorry, computer science. We do things like overload terms. So when I'm talking server here, I'm actually talking about the piece of software that's serving up some information. So, a lot of things we're using Apache or IIS, which was Microsoft's web server. Nowadays, you'll also see Nginx a lot, but Apache still is kind of the one you'd probably see most of. So what Apache does is it's constantly running in the background, and it's listening on the IP address at a given port. Now, the way to think about a port is you only have one cable that plugs into your television. That's kind of like the IP address, but there's a bunch of channels, right? So all of those channels are effectively like a different port. So you can change to ESPN or CNN or whatever else. And on a machine, when you're going to a port, you can go to port 80. 80 is the default port for HTTP traffic. There's other ports like 8000, which is what you're going to use when you are spinning up a Django server. That's just the default port. 5432 is the port for MySQL. 25 is the port for SMTP email traffic. You get the idea. So by default, if in a web browser you said go to this URL, it would ask for something at port 80. And so you might say, hey, can I see your web page, myawesomepets.com, and the server at myawesomepets.com would go to a folder that looked like /var/www/html, and in there would be a file called index.html. Or maybe you said, hey, I want to go to myawesomepets.com/new pet, and then in that var/www/html folder there'd be a folder called my pet with an index.html. This was It's the same thing as if you were trying to open a folder on your computer and you wanted to get a file. This is doing it to another computer. And what was in the HTML page? Well, HTML, the hypertext markup language, is a meta language, a markup language that provides meta information about the information that's being sent. Example, if I said, hello, my name is Mark, and just sent that as text, that's fine. Your web browser would pick that up, say, cool, and just show it on the screen. But maybe I want to say, hello, my name is Mark, and I want it to be bold. So if I did that, I could put a B tag, so angle brackets and the letter B in it, before it and after it, and then the web browser would say, cool, I will show this in bold now. And then you just started adding tags like EM for emphasis, or BR for break, or P for paragraph, or A for hyperlink, which anchor, don't worry about it. Anyway, you'd have all that stuff together, and then that would tell a web browser what to show on the screen. And this was fantastic. We love this. So you could have a piece of text that says, the Revolutionary War, and you'd put A tags around it, link another page with more information about the Revolutionary War. What? This is incredible. It's like you're in a library, except you don't actually have to go get the other book. And that was great. Till it wasn't, and we needed more stuff. And by stuff here, we wanted more dynamic information. So when someone went to a page, maybe it's a page for a business, and the business needs to update in real time how many widgets they have on the shelf. So that's stored in a database somewhere. And so we didn't want to go in and manually change the HTML page every time. That would be absolutely ridiculous. So we wrote code, and that code could be in something like active server pages, ASP, Java server pages, JSP, PHP, which is personal homepage. Anyway, so, or pre-processed homepage, it doesn't matter. We have a lot of languages that Apache how to talk to. So Apache will say, hey PHP, I see that the web page is actually index.php. Hey PHP command line interpreter, CLI, could you like run your code for me and just give me back the result and I'll send it back. So what happens is I say, hey, I want to go to myawesomepets.com, and if the page that I get to is index.php, Apache hands it off to a server, different command line interpreter, to run that code and get the result back. So this was awesome. This way we could actually have things where if you had a web page, an HTML page that had a 4-minute, and you said like, hi, my name is Mark and I love your web page, submit. That would go to a PHP page that would process that text, store it in a database, and all of a sudden we have now created a web application. So much cool stuff. And it got more complex. And as things got more complex, and as we got more users, we had to handle things like scalability. So one server was doing fine if you only had like 100 some odd users. But if the number of users got into the thousands, tens of thousands, that server would just get completely overwhelmed. It couldn't do anything. So we said, oh, great idea. So what we're going to do is we're going to add more servers. Perfect. And now all of a sudden you had the problem where when you made your initial connection, you talked to server A, but on your next connection, you talked to server D, and then server A and server D then somehow had to share information between each other. And that stunk, because that meant that we were trying to do something synchronously. As in, like, we would do an operation, and then the next part of the system would need to know what the next operation was. But the internet is inherently asynchronous, which means you run a command and you expect something to happen, and then all the data comes back to you. How do we fix this? Well, we kind of forced the internet to be kind of synchronous by doing things like managing user session. So this user session would be some bit of information that's stored somewhere. And when we stored that information somewhere, all the servers needed to be able to access it. And that's state problem. If I connected to server A, it would create some like array list or something with information about me in it. And then server D would have to pick that up, and then server D would make changes to it. And then it would be passed around, and we would have this huge amount of memory being taken up in the back end just to keep up with someone shopping at myawesomepets.com. Java solved this by creating Java beans, which I do appreciate because coffee bean, it's kind of fun. Okay, anyway, so these beans were things that were passed around and they represented sessions. But every time then that someone connected to a different server, you had to allocate the bean, you had to recognize what was going on. It got nasty. So statefulness, huge problem here. You think we've gotten better than this? Yeah. If you're at UVA and watching this video, you know what SIS is. SIS, our student information system, works a lot by state. And unfortunately, because of that, weird things happen. What happens when you hit the back button in SIS? A portal opens to a realm of death and destruction. No, it all gets very confused as to what's going on. Same thing if you try to open SIS in multiple windows. It doesn't know what your actual state is, because which browser window am I thinking about? Because they're, it's kind of like quantum. It's like, which one are you in at this exact moment? It's because part of it's written in Java in the back end. Now, look at this link, for instance. So this is from a very old semester, 2017. That is rolling over the link for the choir of people, the 3 people. It's supposed to give you the list of the people in the. We'll talk about usability another time. But here, that link is a JavaScript submit action document.win0 class roster $1. That link is completely dependent on you absolutely being on this page. This is not a link you can right click on, copy link, and post in another browser window and it works. Like you can do with like a Google search or something. Because SIS has to know exact state to work at all times. Not great from this perspective. SIS does other things reasonably well, but this is not one of them. Because we've evolved the way we think about the internet from between verbs and nouns. If we don't think about actions, as in like on that page where it was a JavaScript submit action, but if we thought about, what if I wanted to create a URL that said something like, cis.virginia.edu/cs3240/fall17, something like that, where you could look at the link and know exactly what it was, and it would authenticate you whenever you needed to do it. Wow, that sounds like a dream come true. That takes advantage of the asynchronous nature of the web, because I could take that link and use it anywhere. And so if we can actually create websites where state is controlled when we make the request, as opposed to the servers somehow magically have to remember all this stuff with huge amounts of data, then that's going to actually make our websites work really, really better. That is called REST, Representation State Transfer, which I talk about in another video. Today, I just want to go deeper into just one particular example, Django, which is MVC, Model View Controller, RESTful, client server. This is Django. So what is Django? Free open source web application framework written in Python, which follows Model View Controller. Again, we'll talk about Model View Controller in some other videos, but what I want you to know about Django is that it does a lot of the heavy lifting for you. Could you write your entire application in just straight up Python? Sure, you could. Why would you want to? The reason we use different frameworks is to remove some of the lowest level stuff from the developer so that we can focus much, much more on what we want our application to do, or the actual requirements of our user, as opposed to worrying about how do we transmit data over the. Well, briefly, let's talk about model view controller. If you took 3140, you saw model view controller, but a quick review here. The idea is that our browser is going to send a request to the controller. What is a controller? Controller is a thing that manages the business logic of the data, or the business logic of the system. Be requesting the information, requesting the page, displaying the page, submitting data, whatever it is. The controller takes that request and then talks to the view and says, okay, this is the HTML I need to show with it, and talks to the model to get the data that it needs to actually rebuild the page. Unfortunately, in Django, they name things a little bit weird. So the view in Django is actually called the template. That's where you made those HTML pages that you did for Django practice. The controller are the views. Sorry. But those views are the things that say, when I do like index or things like that, this is what gets called. And then thankfully the models, and those are easy to kind of pick up on. So we like model view controller because it helps us manage changes to the software. It separates our concerns. We could have someone working on the controller, some other people working on the views, templates, someone else working on the data and the models. And it allows us to keep things separate from each other. So if one thing breaks, it's easier to identify. And also we could do things like change out those templates with brand new templates. And all of a sudden we have a new layout for our software, but we didn't have to change any of the business logic. Nice. So the other things that it gives us is those URLs. I showed you that really, really terrible sys URL a minute ago, but if you think back to Django practice, the URLs in Django practice made sense, right? /polls, /polls/1, /poll. Yeah, that actually kind of worked. In a RESTful application, in a good MVC RESTful application, your URLs load a model. So right here, Reddit, we're going to say Reddit is RESTful, which it is. Reddit.com/r is saying get a subreddit, and here the subreddit's asking for is Oscars. If I do /r/all, it's going to get all the ones that I'm subscribed to. That URL, when it comes in, is going to provide the web application, in our case Django, it can be other frameworks, is going to provide that web application with basically a command that it needs to run. So in this instance, we're going to run a particular script, run a command to get a particular page. Here, reddit.com/user/spez. Okay, so in reddit.com, we're looking at the model user, and I'm asking for a particular instance of that model, spez. If I want their posts, user/spez/posts, I'm identifying the noun that I want, and it's giving me back the information that I need. That's what you did in Django practice. That's what you're going to be doing in your project, is a lot of understanding what your models are. How do I set up the URLs? How do I set up that routing so then I get the proper information? Some people ask, why do we still use Django? Because like, oh, but Sheriff, there's so many other cool things out there. What if I wanted to use React and Angular and I don't know all the cool new frameworks. Here's the thing. Django has been around for a while, which means a lot of people use it and have used it and still support it. These are just some of the applications that either use Django or took Django and made modifications to it to kind of make their own backend for their application to work better for exactly what they want to do. Python in general is easy to learn. It plays nice with websites, and Django takes a lot of the heavy lifting off of people. So why not? It's important to remember that not all developers are going to go out and build new stuff, that you're also going to have the opportunity to do maintenance on older stuff. And so still understanding how some of the older stuff works matters. All that aside, Django's just a really good example of an MVC web framework. And if you can understand how Django works, basically understand how Ruby on Rails works, how Laravel works, how Pyramid, name other frameworks. Matter of fact, we're going to be doing some of that too. Why would you choose Django over Laravel? Why would you choose Laravel over Pyramid or Spring or something like that? That's what we're going to do in our next guided practice. So look forward to that. We're going to let you go off and try and find some frameworks to evaluate for yourself. So that's how Django works. Very high level. I know your DevOps manager has done probably some of the heavy lifting here, but it would be really great if everyone took a look at this too, so you knew what was going on with how now a Django app gets to Heroku. So here is a link to an example project, and there's a video on the project resources page that shows how I got it up and running on Heroku. Everyone should be familiar with basically how this process works going forward. So that's what I've got for today. I hope that helps you understand a little bit of how we got to the idea of web applications from very early days of web server is file server. Yeah, take the web apps class as well too to get even more information. But you know, so much now happens in browser. So much now happens in these other pre-processing languages that the web of 1997 is so much different. The web of today and the web of tomorrow. So it's really kind of amazing and awesome where everything. So hope that helps. Let us know if you have any questions. Take care. I'll see you next time.